All right, for this one, we'll split it up into cosine to the fourth x times cosine x dx. Remember, this is cosine to the 1, so when you're multiplying, you add the exponents. That'll give you the 5 there. Now we can rewrite cosine to the fourth x as cosine squared x squared times the cosine x dx. And now we'll use that identity that cosine squared x is 1 minus sine squared x. So you have 1 minus sine squared x squared cosine x dx. All right, and now squaring 1 minus sine squared x, we've got 1 minus 2 sine squared x plus sine to the fourth x times cosine x dx. And now maybe you're wondering how I got from here to here. So let me show you right here. 1 minus sine squared x squared is 1 minus sine squared x times 1 minus sine squared x. Now if you were to do this foiling here, you'd have 1 minus sine squared x minus sine squared x, so there's 2 of those. And then negative sine squared x times negative sine squared x is positive. Just a negative times a negative is positive. And remember, sine squared x times sine squared x is, you can think of that as sine x squared times sine x squared. So you have same base, you got to add the exponents. So that's why we get sine x to the fourth. Oops, sine x to the fourth. Sine x to the fourth is sine to the fourth x. All right, so that's how we got that. Now I'm going to put this back up here. Oops. Okay. Now what I'm going to do is I'm going to distribute this cosine through. So I'm distributing the cosine through to each of these pieces here. Still all of this happening within the integral. So we have cosine x minus 2 sine squared x cosine x plus sine to the fourth x cosine x dx. Now I want to emphasize that what we're trying to do here is often we're reducing down to these forms that I talked about in the first trig integral lecture video, where notice here we could use a u substitution with u equals sine squared x. But to make this a little more clear, I'm going to split up the integral over the minus and the plus to make this into the integral of cosine x dx minus the integral of 2 sine squared x cosine x plus the integral of sine to the 4th x cosine x dx. And now remember, we can pop the 2 out to the front there. So I'll do that. So I'll have 2 like so. Now the antiderivative of cosine is a well-known form. Here we could make u into sine x for the u substitution. Remember that, oh, forgot my dx there. Du, derivative of sine is cosine, so du will be, derivative of sine is cosine x dx. So this will be my du, and I'll have u squared there. And same thing, I can use this same substitution here with u equal sine x for this integral. And that's how you would solve it. I'm not going to take it any further because we've already covered the u substitutions with these. But those are the u substitutions that you would use to solve this.